Hi, I'm Shuwen. Today, my partner Manwu and I are going to talk about Natural Language Toolkit, aka NLTK. We will first briefly introduce NLTK and how to install it. Then, we will show some demos using NLTK. NLTK is a powerful Python package that provides a set of diverse natural language algorithms. It is free, open source, easy to use, large community, and well documented. NLTK consists of the most common algorithms, such as tokenizing, part of speech tagging, stemming, sentiment analysis, topic segmentation, and named entity recognition. NLTK helps the computer to analyze, pre-process, and understand the written text. Here are some goals of NLTK: simplicity, consistency, extensibility, and modularity. It defines a basic infrastructure that can be used to build NLP programs in Python. It provides basic classes for representing data relevant to natural language processing, standard interfaces to performing tasks such as tokenization, tagging, and parsing, standard implementations for each task, which can be combined to solve complex problems. But encyclopedic coverage and optimization or clever tricks are not its goals. NLTK is a leading platform for building Python programs to work with human language data. It provides easy-to-use interfaces to over 50 corpora and lexical resources, such as WordNet, along with a suite of text processing libraries for classification, tokenization, stemming, tagging, parsing, and sentiment reasoning, wrappers for industrial strength NLP libraries, and an active discuss forum. Now let's talk about how to install NLTK. As shown in this page, the installation is very easy. After setting up the Python environment in our computer, we can use the command to install NLTK. After installing the NLTK package, we can install the necessary datasets or modules for specific functions to work. If you are unsure of which datasets or models you will need, you can install the popular subset of NLTK data. On the command line, type python-m-nltk, download the popular, or in the Python interpreter, import NLTK download.
As mentioned before, NLTK is written in Python, so the learning curve of NLTK is also very fast, and it has very good learning kit. NLTK offers many modules to realize different NLP tasks. Here are some example modules. Corpus. NLTK has built-in support for dozens of corpora and learning models. We can use the NLTK corpus downloader to obtain these resources. Tokenize is a package provided by NLTK module to achieve the process of tokenization, which divides a string into substrings by splitting on specified string. Probability module is classes for representing and processing probabilistic information. The stem package is used to remove morphological affixes from words, leaving only the word stem. NLTK can have access to the WordNet lexical resource through the WordNet module. WordNet is a large lexical database of English, which was created by Princeton. It is a part of the NLTK corpus. Nouns, verbs, adjectives, and adverbs all are grouped into a set of synsets. Chunk module offers classes and interfaces for identifying non-overlapping linguistic groups, such as base noun phrases in unrestricted text. The tree module offers class to represent hierarchical language structures, such as syntax trees and morphological trees. Tag package contains classes and interfaces for part of speech tagging or simply tagging. A tag is a case-sensitive string that specifies some property of a token, such as its part of speech. The path module defines classes and interfaces for producing tree structures that represent the internal organization of a text. Cluster module contains a number of basic clustering algorithms. The draw package is used to visualize NLP structures and processes. The contrib module provides the interface to have access to resources that come from many outside contributors. Next, I'll give some examples to show how to implement NLP tasks using NLTK. The first example is tokenize and tag some text and then do the identify named entity. Given an input sentence, we can use NLTK.word tokenize to do the basic word tokenization. NLTK.pose tag is used to tag each word in the text. Each word has a tag which denotes its part of speech. Chunking is one of the important processes in natural language processing, which is used to identify parts of speech and short phrases. The chunked text is represented using a shallow tree called a chunk structure. Here, NE-chunk is NLTK's currently recommended named entity chunker to chunk the given list of tagged tokens. The second example is displaying a path tree. We import treebank corpus and use treebank.pathSense to show a path tree of a sentence. The third example is do the stemming. Stemming is a technique used to extract the base form of the words by removing affixes from them. It is just like cutting down the branches of a tree to its stem. For example, the stem of the words connection, connected, connecting is connect. NLTK has Porter stemmer class with the help of which we can easily implement Porter stemmer algorithms for the word we want to stem. First, import the Porter stemmer class to implement the Porter stemmer algorithm. Next, create an instance of Porter stemmer class. Here is PS. Finally, call the stem method and input the word you want to stem. The fourth example is nemmatization. Nemmatization technique is like stemming. The output we will get after nemmatization is called nemma. It transforms root word with the use of vocabulary and morphological analysis. Nemmatization is usually more sophisticated than stemming. Stemmer works on an individual word without knowledge of the context. But after nemmatization, we will be getting a valid word that means the same thing. NLTK provides WordNet Nemmatizer class, which is a thin wrapper around the WordNet corpus. This class uses Morphe function to the WordNet corpus reader class to find a lemma. First, import the WordNet lemtizer class. Next, create an instance of WordNet lemtizer class. Finally, call the lemtize method and input the word of which you want to find the lemma. The last example is displaying the frequency distribution. The probability module offers classes to represent and process probability information. The freqdist class is used to encode frequency distributions, which count the number of times that each outcome of an experiment occurs. In this example, it counts the frequency of each outcome word. There are many learning materials of NLTK online. We can check them for reference. Thank you. This is the end of our presentation.